Welcome back, YouTube family. So let's get started with session 4 of the series Java Full Stack Made Easy. In the previous session, we spoke about what? We spoke about the primitive types, and at the end, I was discussing about the Boolean type of data type, and also like in the previous video, I promised you that I'll be focusing on one more concept, that is char data type. Why is it of 2 bytes in Java comparing to 1 byte in C++? So let's focus on that, and we'll move ahead and we'll talk about the next type of data type in Java, that is class type data type. And also I'll give you few tips and tricks which might help you in your OCGP exam. All right, so point number 1 is this, that is why in Java a char is of 2 bytes, whereas in C++ a char is of 1 byte. So C++ char is of 8 bits, 1 byte is 8 bits, and whereas Java characters are of 16 bits. Okay, so now any character, if you might have noticed in my previous example also, any character that I'm declaring, and if I declare a character like this, if you remember this previous example, if I say char x equals to 65, I was getting a, right? That is the ASCII value of 65. So that's what we were getting. So each character is associated with an ASCII value. Okay, and ASCII values they are under 127. So all ASCII values are less than 127. Now all ASCII values are less than 127 indicates what? So they are what? 26 alphabets, capital case alphabets, 26 small case alphabets, then 10 numbers, and then the special symbols. So all of them can be included into a character. So whatever special symbols we have, numbers we have, and whatever we have, they fall under 127. Each of them is given a number. Means each of them is given an ASCII value which is below 127 only. Okay, so as one more point, I told you that this let's say 1, writing 1 like this, which will be a character. Now 65 was converted into a, right? Now I'm writing 1 here. Okay, 1 is not equal to 1, right? Like 65 was not equal to 65. So 1 will not be equal to 1. So similarly, if I say 48, 48 will not be equal to 48, correct? So 48 is equal to what? 48, it's saying 0. Let me give 49. So what is 49 now? 49 is 1. So if you remember, I told you writing this 3 and writing char 3 gives you a different result, right? That's because in the above case, the x is character 3, so it will be printed as it is. And like I told you, 48, 49 and all that. So now you count and you guess what's going to be the result for y by the time I run this. So the below case, what I'm writing, char y is y equals to 3 and char x equals to 3 here. 3 will be considered, this x will be considered as 3 itself, but for y, whatever is value for 3, the ASCII value of 3 will be given to you. Okay, not 3. So if suppose I write something like let's say 51, okay, and save it and then run this, I get what? 3. So that's why in previous video I told you 3 in character and 3 as written as an integer will be different. Okay, now going back to what I was saying here. So each of the character, each special symbol, or be it a number or a capital case character or a small case character, they all have given a, we have given a ASCII value to all of those characters. But now Java says that my character is of 16 bits. So why is that? Why did they increase the size of it? Although even in C++ and all, we used to give all these special means we used to write all special characters capital case alphabets, small case alphabets, and numbers also. So because they fit into this. Now what Java is trying to make, now what special thing Java is trying to bring in? Java is trying to bring in something called as localization. Now, what do we mean by localization? On Google, you might have seen, you can see Google on in Hindi language or Gujarati language or maybe Chinese language and all. So Asian language alphabets, they do not fit into ASCII. Okay, like this. Suppose if I want to have this thing in my character, so it will not fit into it. Asian language alphabets do not fit into it. Because of that, and higher range will be required. And 16 bits characters are actually Unicode characters. Okay, so now it is 16 bits. So we have what? The last bit is gonna be what? 15. 16th basically will be reserved. That means if I take from 0 to 15, that 15 index is reserved for the sign. Rest all can be utilized. Okay, so that's an important point. That is why Java made character as 2 bytes rather than 1 byte, so that we can include even the Unicode characters, not just the ASCII characters. Okay, and from this particular example, we should also be noticing that 3 written as a character in single quote is different, and 51 is actually 3. So 51 is not 51 here, 51 is 3. So let me just put this into the repository now. So this is our day 4 of Java full stack. So let's create the day 4 repository. Day 4. And this is my demo 1 Unicode character. Okay, so although I have not written any Unicode character there, so let's say char and put this. Fine, I'll make the changes. Now let's go back, and also, as I told you in this video, you will be seeing some tricks that will be used in the exams. So this is one of them. They might give you char y equals to 3 and x is equal to 3, and they will ask you whether both are equal or not, or at times they will ask you the result of the system.out.println and result of this. Okay, or they might write 51 and then they might ask you the result of this. So do not say that the result is going to be 51. Now the next point is, let's talk about the default values. Everything that I have written here, the byte, short, int, long, float, double, char and boolean, everything has a default value with it. So all of these numeric values, they have the default value as 0. Decimal values, they have 0.0 as a default value, and for character it is a /u0000. That is a Unicode character, which is a default one. You will not be seeing this because character holds only one thing, right? So this is what Unicode code of the character that is given as a default one. Okay, an empty space you will get, and for boolean it is false. So these are the default values of the primitive types. Now again, default values depend upon what type of variable you are creating, because if you create a local variable, we have already discussed, local variables don't have the default value. For example, here if I declare a character, or maybe if I declare boolean z nothing, okay, and if I try to print that z, I will get nothing at all. That is because of what? Because local variables don't have default values. So the moment I write z here, I am going to get an error saying that the local variable z might not have been initialized. So although each of the data types, primitive types, they have different default values, but it depends on what type of variable you are creating. Even if I write it like this, still it is going to give me an error. That is because this is an instance variable. I am trying to call it into a static function without an object reference. That cannot be done. So that's why I'll just add a static to this. So static boolean z, now it gets a default value, and you will see that the default value is false. Okay, so each primitive type has a default value. Even if I declare something like byte here, byte b equals to nothing, be it byte, short, int, long, or let's say float, f equals to nothing. So in all that cases, you will get the default values. Even if I write a char, you won't be able to see this but it will be slash u0000. So let me print the byte value and also the float value. So byte value will be definitely 0, float value will be 0.0. So that's how default values are taken in Java. So let me just save and run this. So here we get the result, false 0, 0.0. Okay, I'll put this again into the repository. This is just the default values. So that's my demo to default value. And also what I suggest you is you go through with the codes that I'm writing here, you play along with the codes, and just listening to my videos will definitely give you an idea about it, but then practice is something that will make you perfect. So I always encourage people to practice on their own, okay, rather than just watching this and leaving it there itself. Fine. So it will definitely take some time, but if you want to learn something, then you have to give time to it. All right, so next, again, another trick I will tell you what they might trick you when coming to the default values, how they can trick you. So now I'll clean up everything and I'll focus only on the main part. So system.out.println, suppose I'm writing Z here. So now I will ask you, what is the result of this? You will definitely say it is Boolean, no value is given, then the default value false has to be given. So when I run this, it is false. That's correct. So what they might even do with you is that they might give you something like this, and then they will ask you, there is Boolean, that is valid value, and I just copy paste and then I try to print that Y. So when I try to print that Y, since you see that it is Boolean, okay, it is Boolean. Why? So what is the Boolean? First of all, it is valid, right? And then you might not focus on this. This is small case character, this is capital case character, right? So when I run this, as I told you, for the value Z, it has to be false. But for this Boolean, it is a different Boolean given there, not just the Boolean primitive type. So for this, all of this objects, all the class types are null by default. So when I run this, you will get the result as null. So that's because class types are objects, they are null by default. All class types are null by default. So they might give you something like this and then ask you what would be the default value printed. So notice that when it is Boolean primitive type, it is false. When it is Boolean class type, it is null, because all class types are null by default. Now you might be thinking, what is this Boolean? So my next topic will be focusing on that Boolean itself. So first, let me just put this into the repository and we will talk about what is that Boolean that is coming up with a capital case character. Okay, Boolean. Done. All right, so going back to our code, so let's focus on what is this Boolean coming up with a capital case character. So each of this, so but before going to this Boolean directly, what I'm gonna do is I'll give you another example of a class type data type. So while talking about the class type data type, so if you see in primitive types, you don't see anything called as string there, which is a set of characters, right? So when we don't have a set of characters being given to us, so we have to be using string, right? So now let's see how strings work in Java, because string is not part of a primitive type. So let's go for string, and let's say string t equals to test, right? And then system.out.println t. So this is how we generally declare a string in Java, which is not a primitive type. Now let's run this and we get that test here. So sometimes what might happen is a string is a set of characters that can hold anything, right? It can hold alphabets, it can hold numbers and all. So if suppose I'm trying to read something from a user, or maybe a user has given something like this, a string num equals to 10. So this is a valid string, okay? And what I want to do is I want to convert this num into a number, okay? So let's call it as strnum. So that's what I'm trying to do. So an strnum is something which I want to basically convert into a number, an int value. So if I try and do something like int, let's say num equals to str num. So when I try to convert this, obviously in the previous session also we have discussed about what typecasting. So here also I am trying to perform a typecasting, and I see that type mismatch cannot convert from string to int. Okay, that's fine. So what we have learned in our previous sessions was typecasting it this way. So convert a string into an int. But when I try to do this, I still get an error. Now it says cannot cast from string to int. So you just notice it here. Now it is saying cannot cast from string to int, and in this case it was saying type mismatch cannot convert from string to int. Okay, so now you can say this thing which I am trying to do is correct. Type mismatch cannot convert from string to int. So this is what the result of my data. Now when I try to convert it, it's basically telling me that I cannot convert a string into int. Now why is that? So previously when we were trying to perform typecasting, it was happening perfectly fine. So it was conversion from int to byte, right? So that is what we have seen, and then long to byte, or maybe the main thing which we have seen is from int to byte itself, higher value to lower value conversion is required, right? So now when I am saying that convert it from string to int, what I am mainly doing is I am trying to convert a class type into a primitive type. Class types are object, whereas primitive types are simple values. So what is happening internally? So when I say this str num, since it is a class type, it is a class. So because it is a class, so I can have the functions for that. You can see that for string I have char at and all that. Maybe for string you might have specially used this method a lot of time, that is length of a string, or maybe I can convert a string into uppercase, or maybe I can convert it into a lowercase, right? So these are the functionalities that are associated with the string because it is a class type. Class types are objects. So objects are what? They are nothing but instance of a class. So a class is a blueprint containing all the data members and member functions. So if I convert this class type into a primitive type, all that will be lost, right? So it will not be that easy to convert a class type into a primitive type or a primitive type into a class type, because the entire category of data type will be different. So Java says you that apart from this 8 primitive types, rest all is object itself in Java. So how do we manipulate this primitive types as an object in Java? So Java says bring in the concept of something called as wrapper classes. So each of the primitive type is associated with a wrapper class. So a wrapper classes are basically used to consider primitive types as an object, or you can say manipulate these simple values which is primitives as objects. So if you want to manipulate primitives as objects, use wrapper classes. So they act as a bridge between your primitive and class types. So now these were the 8 primitive types. For all of the primitive types we have a relevant wrapper class. Like for byte, let's say short, int, long, char, boolean, float, double. Okay, each one of them is associated with a wrapper class, and you don't need to worry about the wrapper classes. It is a class, right? Wrapper class. So it's a class. Java rule says that classes should begin with a capital case character. So if I was one who was developing Java programming, for byte a meaningful name would be byte itself, right? Because the classes start with a capital case character, I'll give it with a capital case character. For short, again, it is going to be short. For long, it is going to be long. For boolean, it is going to be boolean. So here is the class that I was using in the previous example, where all class types were null by default. So I was actually using a wrapper class there. Okay. For float, it is float. For double, it is double itself. So now you can notice that I have not written 2 wrapper classes here, one for char, another one for int, because for int it is not int, it is integer. For char it is not char, it is character. Okay, So wrapper classes, only these two wrapper classes are named differently. For int it is integer, for char it is character. Okay, so for rest all things it just starts with a capital case letter because it is a class. Fine. So anything that you want to convert from a primitive to class or class to primitive, in that case you have to make use of the wrapper classes. Okay, you have to make use of the wrapper classes. If your conversion, if your typecasting is from class type to primitive type or primitive type to class type, so conversion of data from primitive type to class type, the concept is called as boxing. Okay, so this is another concept you might have heard about, that is boxing. Conversion from primitive to class type. Okay, primitive to object or primitive to class type is boxing, and there is another concept called as unboxing, that is class type to primitive type. Primitive to class is boxing, class to primitive is unboxing. So what I have here is, I have a class type data type here, I want to convert it into a primitive type int. Okay, so this is invalid, cannot be converted without without a wrapper class. So you need a wrapper class for this. Why is that? That is because string is class type whereas int is primitive type. Okay, because string is class type and int is primitive type. So whenever you are converting a class type into primitive or primitive into class, wrapper classes comes into picture. They act as a bridge for you. So let's see how do we convert this simple string value into an int value. It's not like we cannot print this, we can do anything with the string. So now I want to convert it like this, int num equal to, now str num is something which I wanted to convert, right? So for that we needed what? We needed a integer, that is the wrapper class. So let's go for that, integer. So this is a class, because it is a class it will contain methods into it, right? It will contain variables into it. So there is a method here called as parse int. You can notice that the method parse int takes a string argument. So I hit enter and I give the string argument string num and I save it. Now this num system.out.println, you print num. So now this num is like a number, it's not a string. Now how do I prove that it is a pure number, not a string? So let me just give you that example as well, system.out.println. Now if I do str num here plus 55. So we know that this plus operator either concatenates two values or it adds up two values. So when it encounters a string value and an integer value, it has to concatenate it because it cannot add those two things. So it has concatenated that 10 and 55. Same thing I will write with the number here, system.out.println num plus 55. So at that time, since num is of type int, it is a converted value of string str num. So now it is purely converted into a number. Because it is converted into a number, it should add the values 55 plus 10. So that is going to be 65. So here is the use of your wrapper classes, and also the concept of boxing, conversion of primitive type to object, or unboxing where we convert a class type into primitive type. Okay, so let me just copy this and put it into the repository, and I hope there are now in a broader level, while typecasting the data, again you have what? You have typecasting, you have boxing and unboxing. Okay, so this is my demo file, I think, and this is what boxing and unboxing. Okay, for boxing and unboxing we have to bring in the concept of wrapper classes. So this is how things work with the concept of typecasting. And in the previous example, when I was talking about boolean, I was actually taking what? I was taking this boolean wrapper. So since it is a wrapper class, and wrapper class is what? It's a class type data type. All class type data types are null by default. So I hope you have understood what exactly is the concept of boxing here and the concept of unboxing as well. So I have added this into the repository. Let's make this video a short one. In the next video, I'll be explaining you about the string class. We'll go in details about the string class, and more of the wrapper classes will be used in our next video. So till then, see you. Have a nice day. So if there is any question, you can ask the question in the comment.